If the asteroid that wiped out the dinosaurs were to hit Earth again, could humanity survive it? There are rumors about asteroids hitting Earth almost every year, but if you ask whether an asteroid has really come, hey Tadagata! According to NASA's estimates, an asteroid named Bennu is expected to collide with Earth in September 2185, so everyone should pay attention when the time comes. In fact, asteroid impacts on Earth are actually very common. Dozens of asteroids enter the atmosphere almost every year, but because they're so small, no one really notices. Dozens per year might seem like a lot from Earth's perspective, but if you look out into the universe, there are even more asteroids in the solar system just waiting for us. There are 800 asteroids in the main asteroid belt between the orbits of Jupiter and Mars. With such a huge number, it might seem to Earth like a weasel rapping and dancing danger lurking beneath the surface, but in reality, there's no need to worry at all. As for why that is, we have to thank the second hero of the solar system, our big brother Jupiter. As we mentioned in a previous video, Jupiter's mass is 318 times that of Earth's. The greater the mass, the stronger the gravity. And in the universe, bigger is better. Bigger means stronger. So if an asteroid wants to hit Earth, it first has to get Jupiter's permission. Returning to the question at the beginning, the asteroid that wiped out the dinosaurs was 10 kilometers in diameter. If something like that happened again, and you happen to be directly beneath the impact point, you'd immediately become part of the carbon cycle. It would just be a fatal blow, completely painless. And years later, you might even turn into a fossil. But if we're far from the impact side, then things become less certain. Back when the dinosaurs were hit by the asteroid, it actually took them about 2 million years of struggling before they finally went extinct. If the dinosaurs could hang on for 2 million years, then we should definitely be able to survive as well. It's just that the Earth would go into vibration mode, making the surface uninhabitable, so we'd have no choice but to live in underground cities. The quality of life would inevitably decline. But then again, with how advanced human technology is today, we definitely wouldn't just stand there and take an asteroid hit head on. As for smaller asteroids, we don't need to worry about them. They'll burn up from friction with the atmosphere and won't even make it to the Earth's surface. And even for asteroids with diameters of several dozen kilometers, it's not as if humanity is completely helpless. When people imagine a meteorite hitting Earth, they often picture an asteroid charging straight at us like a runaway horse. But in reality, every asteroid in the solar system has its own orbit. They all follow their own regular path. A collision will only occur if Earth's orbit and the asteroid's orbit intersect at a common point. So the method to prevent an asteroid impact is pretty clear. Either change Earth's orbit or change the asteroid's orbit. As everyone knows, altering Earth's orbit is just a little bit difficult, so we can only change the asteroid's orbit. We can simply launch a nuclear bomb directly at the asteroid and blow it up. Of course, in the vacuum of space, there are no shockwaves, so the power of a nuclear bomb is limited and can't actually destroy an asteroid. But we don't actually need to blow the asteroid to pieces. We just need the heat from the explosion to generate a small amount of thrust to alter the asteroid's orbit. We could also launch an artificial satellite to collide with the asteroid. Back in 2022, the United States launched a satellite probe to crash into an asteroid, and they successfully changed its orbit. But honestly, sending a probe to crash into an asteroid, I can't help but suspect they learned this method from the Chicxulub. In addition, some astronomers have proposed the concept of a gravity tractor. When the asteroid is still far from Earth, a probe of sufficient mass could be launched in advance to fly around or alongside the asteroid. There's no need for a collision. Due to the force of gravity, the asteroid's orbit would undergo a slight change. To put it simply, it's like using the gravitational disturbance of a small probe to achieve the effect of a small horse pulling a big cart. As the saying goes, a tiny error can lead to a huge difference. A small change in the orbit, when magnified over cosmic distances, can result in a deviation large enough for the asteroid to completely miss Earth. Of course, for any of these methods to work, the prerequisite is that we must detect the asteroid in advance. Suppose we discover an asteroid that will hit Earth in 2.5 years, then we have enough time to issue an early warning, make plans, and get prepared. But if, say, the asteroid is going to hit tomorrow and you only find out today, then you really have no choice but to take the hit head on. It's like remembering to do your homework on the last day of a long holiday or realizing you need the restroom only when your dad's already at the hospital entrance. How could you possibly make it in time? But at the end of the day, there's no need to be overly afraid of all those rumors about asteroids hitting Earth. Rumors. After all, if I don't hype them up, who will? If I don't, the marketing accounts will. If the marketing accounts don't hype them, how are we supposed to get any traffic? And as I mentioned earlier, in the universe, asteroids just go wherever the strongest gravity pulls them. Asteroids within the solar system, tempted by Jupiter's massive gravity, will obediently stay in their own orbits, and asteroids from outside the solar system will also be captured by Jupiter when they enter. With Big Brother Jupiter watching over us, what do we have to be afraid of? The solar system can't lose Jupiter.